Example 13.4 Part D asks us to completely factor the equation g of x equals 3x cubed plus 2x squared minus 12x minus 8. And this looks a little different than any of the other examples we've seen because this example has 4 terms. And the more terms that you have, the more difficult it is to be able to find a greatest common factor for all of the terms. There is a particular factoring technique that I always try whenever I have 4 terms. It is called factoring by grouping. And I have given factoring by grouping a nickname. I call it triple GCF. If you find yourself to be good at GCF, then all you'll be doing here is just applying it 3 times. So you should be pleased to hear that it's really just several greatest common factorings all rolled into one. Now it's the way that you do your GCFs that makes it the factoring by grouping technique. So like I said, the more terms you have, the more difficult it is to find a greatest common factor for all of the terms. So I don't want you to look at all the terms. I want you just to look at the first 2 terms and then look at the second 2 terms separately. And we're going to identify the greatest common factor for each one of those and factor them individually. So g of x is now going to say x squared times 3x plus 2. And the second grouping, I would say, has a common factor of 4, which is going to give us negative 3x minus 2. Now, once I do that, I change the structure of my equation a little bit. In the original written equation, there is 1, 2, 3, 4 terms separated by the additions and subtractions. In the new version of the equation that we have, after doing 2 GCFs, we now have 1, 2 terms. And what we're looking for is, what do these 2 terms have in common? They almost have 3x plus 2 in common, except one of them has negative 3x minus 2. So rather than just pulling out a 4 from that second group, let's pull out a negative 4. So let's go ahead and pull out an extra negative 1 to go with this. So g of x is now going to read x squared times 3x plus 2 minus 4 times 3x plus 2. So I still have 2 terms, but now I have something in common with them. They each have a 3x plus 2 in common. So I can factor that out from these 2 terms, giving us 3x plus 2 times x squared minus 4. So that represents the factoring by grouping technique. But remember, key word here is completely factor. We are not supposed to just stop here if there's more to do. There is more to do with x squared minus 4. This will be an opportunity for us to be able to apply the difference of 2 squares technique. So applying the difference of 2 squares technique, if you need to go back and review that, we did a more detailed look at difference of 2 squares in example 13.4a. For here, for this example, I'm going to go right to the factoring. It'll be x minus 2 times x plus 2, and that would be equivalent to the x squared minus 4. This gives us 3 factors, and all of these factors are linear. This is a linear factorization. And this time I'm going to use the factored form to determine the degree. The degree of this polynomial is going to be 3. Since each one of these is linear and there's 3 of them, 1 plus 1 plus 1 gives me a total of 3.